For this belt work, we gotta translate this. We gotta figure out what the translation is though. So all we gotta do is find any corresponding points, such as, I'll just go to the far right here for figure U and V. Now, even though I've got these corresponding points though, we need to figure out which of the two figures is the image and pre-image. And it says determine which translations would map figure U onto figure V. So this means that they would have to move figure U onto figure V, which means that figure U there, figure U would be our pre-image. And it also means that figure V would then be our image. So it's the figure that we end up with. The pre-image is the figure you start with U, end with V. Okay, so this means that I'm starting at this red point and going to this one up here, and I gotta stay on the grid line, right? So for this, I can see that I would have to go up, looks like to this line right here. It goes up, and then from there, I'd have to go to the right. Now that we know this, all we gotta do is figure out how far up and to the right. So I gotta count boxes. I'll start with up, 1, 2, 3, 4, 5, 6. So it went up 6. And then how far to the right? 1, 2, 3, 4, 5, 6, 7, 8. So it goes up 6 to the right 8. That is the translation. And I guess we can type it out so it looks pretty. But the translation is up 6 and to the right 8. You could say units if you want, but I'm okay with what we got right there. So here's these two objectives. I can identify reflections, and also I can reflect figures. So take 30 seconds and copy these down too, please. So the nice thing about these reflections really is that, kind of like with what we saw with translations, they're not going to actually change the size of the figures. But it's another way to say reflection is to flip it. Now you'd have to be careful with which direction you're flipping it, right? Because you could flip it left and right, you could flip it up and down. But we'll hopefully figure out how to know how things are being flipped, because we're going to be looking at these on coordinate grids. So yeah, reflection is the same thing as mirroring. So you have some kind of mirror line, right? So let's pretend like I can draw good. And if you had some kind of image right here, I don't know. Let's pretend like I can draw good here. Okay, so it's like taking this one right here, and again, it's not just that it's translating like this. Let's see if the technology will work. But it's been flipped. See, like that. But it's been flipped over this line. Okay, now it says that the figures have to be the same distance from the mirroring line. That's true. That's how mirroring works. So in other words, if this was your face, which shouldn't be so square or rectangular, but if this was your face and this was a mirror, the image that you're seeing of yourself, you're the pre-image, of course. I'll use this one as the pre-image. The distances are supposed to be the same, and again, we're pretending like these are good drawings. So this distance here is the same exact distance as this one right here, okay? And again, I am comparing this with the points. So you could say even this top point right here, which corresponds with this top right corner as well, those are the same distances. Okay, so they have to be the same distances. And yeah, we can see again, remember the technology did this for me, but it flipped this so that it's across the mirroring line. So again, it's just the orientation flips. For us right now, the mirroring line will usually be at least vertical or horizontal. We shouldn't see any diagonal reflection lines. And that's what we would call this right here, the line of reflection line, whatever you want to say. But next year, when you guys go over this stuff, they're going to start showing you how to do this with non-straight vertical or horizontal lines. They can be diagonal as well. And like I said before, reflections do not actually change the size. So that's why I just was able to copy and paste this one and then use the technology to flip it. In fact, in some cases, the points that correspond with each other will be on the line of reflection. If that happens, then it just means that the 2 points should be pretty much at the same point, because if something is zero distance away from the line of reflection, which means it's on it, then its reflection will also be on it, because reflections, points are the same distance away, corresponding points are the same distance away. So this one, it's asking, is this a reflection? If so, which axis is it being reflected over? Now, if you don't remember the axis, the horizontal axis is what we call the x-axis. It's this one right here. And the vertical axis, this one right here, they're usually a little bit darker than the other grid lines. That's the y-axis. So even though these ones weren't labeled x and y, it's important that you know that they are. And this one we can see right here, right? We got this point B. Just right there, thank you. And then we got B prime right here, which means just from this information that they've given us, I can see, now this one right here is our pre-image, triangle ABC, and then since this second triangle here has prime marks, this would have to be the image. Now, if you were to look at these, it's saying, is this a reflection? Well, if it's a reflection, it has to be flipped. So we can really just ask, has the pre-image been flipped? And from what I can tell, that's a no right here. This looks like a translation to me where B has been translated 3 to the right and then 1, 2, 3, 4, 5 down. Now, just to make sure that it is a reflection, I can do this with 2 points, like point C. 3 to the right, 1, 2, 3, 4, 5 down. 3 to the right, 5 down, 3 to the right, 5 down. This is not a reflection. This one is a translation, which is what we saw in that last lesson. Again, we can tell this one hasn't been flipped. If it had, let's see if the technology will do this, especially with an up and down motion like this. At least that's the way I was looking at it. It should look something like this one right here, okay? So if it had looked something like this, something like it, then we could have said that it was a reflection. But it doesn't. So it's a translation, it's not a reflection. All right, how about this one right here? Is this a reflection? Yeah, it is. Because we can see that it has been flipped. And like I said, I can use some technology here just to show that that has happened. So again, if I was translating it, maybe this one went straight down like this. You can see that the orientation would not change. But since the orientation did change, it has been flipped this way, okay? I'll get it out of the way so we can see that. Now, it is a reflection, sorry, reflection. So the first question is a yes. If so, which axis is it being reflected over? Since it's going up and down, this x-axis right here would have to be our reflection line, right? And again, if that happens, then the point should be the same distance from the line with corresponding points on the image, right? So A, right, is 1 up, A prime is 1 down. C is 2 up, C prime is 2 down. B is 4 up from the line of reflection, B prime is 4 down. So again, this is another way to just kind of prove that it's a reflection, but my main point right here is that which axis is it being reflected over? It's the x-axis. Is this a reflection? So again, the question really is, has the triangle, because that's what it is, been flipped? So we'll figure this out, and just a visual check on this kind of looks like it has, even though, well, for this one, the line of reflection is actually right on this y-axis. We'll pretend like I drew a straight line. So if so, which axis is it being reflected over? So which axis, yeah, like I said, it definitely looks like we're looking at the y-axis, but we still need to determine if it actually is a reflection. If it is a reflection, then each of the points that correspond with each other will be the same distance away from this line of reflection. So if you look at A, I can see that's 3 units to the left. A prime should then be 3 units to the right. See, it's in the opposite direction from the line of reflection. Okay, well, how about point C? Well, I can see C, the pre-image point is 3 to the right, which means its image point would be 3 to the left, and it is. There's C and C prime And then B, this one's a little bit unique because, like I said, if it's on the line of reflection, like this one is, then the image and pre-image will be in the same, at the same location, which in this case is 0, 4. And it is. B and B prime, they're exactly the same. They are 0 away from the line of reflection, which tells us that since all 3 points are the same distance away in opposite directions, we are actually looking at a reflection. So the answer to this one, say yes. It is a reflection. Is this a reflection? This is not a reflection because we can see that it's kind of long horizontally here, and then suddenly it's long vertically. And if it's long horizontally like this one, like this trapezoid looks like, or I guess it's a parallelogram. If it's long like this parallelogram, then it should just be flipped, right? So if we were to have a reflection, it would be like moving it here perhaps, or remember it has to go through some kind of flipping motion. So if I did this to it, it would flip and perhaps look something like this one. Definitely not like this garbage right here. So this one, is it a reflection? No, it is not. So we don't actually have to worry about it being reflected. Now you may wonder what type of transformation this is. This is a rotation. So this means if you were to go back to the original, this one right here, right, so there's E, F, G, something like that. You could rotate it. See if it'll let me do that. Yeah, technology won't let me do it, sorry about that, but it is definitely not a reflection. It will be rotation, which we will see. So, reflecting figures, find the mirroring line, the line of reflection. I believe they may give that to us. Oh, maybe these ones are gonna give us the reflection on the, in other words, they're not gonna be asking if it is a reflection. They're gonna say it's a reflection, show what's happening, I suppose. So part 2 here, determine how far points are from the mirroring line. 3, the reflected points are on the other side of the mirroring line. They should be. And then connect the points to make the same mirrored figure. And again, this may not make a lot of sense, even though we have seen a reflection now. But hopefully after a couple examples we will. So it may ask us to actually reflect the figures, which we know. If we can find the mirroring line, which they will give to us, very generous of them, then we just got to figure out how far points are from the mirroring line. This is usually on the pre-image right here. Okay, and then we will reflect, we're going to reflect the points on the other side of the mirroring line, which means they should be the same distance away from the mirroring line, just on the opposite, in the opposite direction. So if your pre-image point is to the right, your image point should be on the left, if it's a vertical line of reflection. If it's a horizontal line of reflection, we're looking at a reflection up and down. So if your pre-image point is up, the image point will be down, and vice versa as well. Then once we get all the points reflected, then we just got to connect them. That's it. Yeah, here we go. This one says reflect the figure over the line y equals -1. And they've even shown the line y equals -1 right here. And I would even say that this one's kind of far away. It's farther away than I would have expected, okay? So to do this, I'm going to identify all 3 points. I'll start with one, though. I'll start with this one at the top. Okay, now it's a reflection. It should be a straight shot to the line of reflection, which is the line y equals -1. So how far away is this line? So we can see it goes from here to here. That's 1, 2, 3, 4. And in fact, maybe I put that arrow on the wrong side, right? From the line of reflection, it's 4 units down. Which means that its reflected point should be 4 up. Okay, because remember, each point is the same distance away from the line of reflection. So I could count this from that line of reflection, 1, 2, 3, 4. So it's going to go all the way up here. And that would be my corresponding point on the new triangle that has been flipped. Okay, but I have to do this with all 3 points. So I'm going to do this, I'll go to this one on the bottom left here. So again, how far away is this from the line of reflection? Well, it's 1, 2, 3, 4, 5, 6. You'd have to go 6 down, which means that its reflected point would be 6 up. And again, this is from the line of reflection. So I've got to go 1, 2, 3, 4, 5, 6, up 6 units here, and that's my next point. Now, even if we were just to connect these two, hopefully we can see that reflection of the line that corresponds with this one right here. It's this one. It's been flipped. Well, let's do it with the last point here. This one in the bottom right. So from the line of reflection, again, it's going to be down from the line of reflection. How far down? This far down. How many boxes is that? 1, 2, 3, 4, 5, 6, 7. So if we have to go down 7 from the line of reflection, its reflected point would be up 7 from the line of reflection. So 1, 2, 3, 4, 5, 6, 7. That takes us all the way. Oh, that's not far enough. There we go. I went 7 up. That's this point right here. Now that I have that, I can draw connections between this green point and the other 2 points. And now we can see the reflected image of our pre-image there at the bottom. And there we go. That is reflecting over a line of reflection. So this figure right here has 1, 2, 3, 4, 5 points. But the line of reflection is a little bit closer. It's x equals 4, no problem. Because, like we've done on that last problem, all we're doing is picking points and seeing how far away they are from the line of reflection. We're going in the other direction from the line of reflection, and that tells us the exact same distance, by the way. That tells us where the new point is. So I'm going to start with the one that's furthest out to the right here. So from the line of reflection, I can see that this is to the right. But again, how far to the right? 1, 2, 3, 4, 5 boxes. So it's 5 to the right from the line of reflection, which means its reflected point has to be left the same distance from the line of reflection. So 1, 2, 3, 4, 5. So I go to the left 5, that would give me this point here. But like I said, I'm going to do this with all the points. I'm going to go next to the topmost point, which is to the right from the line of reflection. How far to the right? I count 2 boxes. Well, if this top point is right 2, then its reflection should be 2 to the left from the line of reflection. Left 2. So that is where my topmost point will be. And like I said, we just got to do this with all the points. So this next one right here that I'm doing in purple, I can see that that's to the right 2, just like the red point was. So that means its image would have to be left 2 from the line of reflection. 1, 2. There it is. Now you can connect the points as you go, like I did on that last problem, but I'm not. I'm gonna make all the points and then I'm gonna connect them. But you can do them at any time. So next for me, I'm gonna use this one, which looks like it's just to the right 1 unit. To the right 1 there from the line of reflection, which means its image would have to be left 1 from the line of reflection. It's going to put this point here. And then my last point, the one at the farthest down, well, that's 2 boxes from the line of reflection. That's left, to the right 2, which means that its image would have to be left 2 boxes from the line of reflection. 1, 2. So that's this point right here. So now that I have all the points reflected, now I can just connect them. I'll use some technology this time so that it looks better than my crappy drawings. So there's this one and this one. I guess it still kind of looks like not very good, but there you go. That's not too bad. It's better than I would have done by hand. That's the reflection over the line of reflection, which is x equals 4, that blue line, which again, they will give you on the assignment. It's very generous of them. But that's all you got to do on this. Let's go into this one. So I can see a horizontal line of reflection here in blue. It is the line y equals 3, which they're going to give us that information, but they're going to give us that line on the graph as well. But we've got to look at each of the points from our pre-image, which we can see is this, I guess, pentagon in red there. And it doesn't matter which point you start with. For this one, I'll start with the topmost point, this one right here. And in relationship to the line of reflection, all I'm doing is seeing, I'm pretty much going straight down to it. Okay, now for the grade that we're in, 8th grade, we only have vertical and horizontal lines of reflection. In 9th grade, I believe they're going to start making those diagonal. But for now, we don't have to worry about that. So how far away is this blue point from the line of reflection? So I can see it goes down here. How many boxes is that? 1, 2, 3, 4, 5, 6. So I can see that, well, actually from the line of reflection, it would be up 6. From the line of reflection, which means from the line of reflection for its image point, I'd have to go down 6. 1, 2, 3, 4, 5, 6. So this is going to go down 6 here. And this would be my new image point compared to that uppermost point. Hopefully your drawing looks a little bit better than mine too. Now, like I said, it doesn't really matter which point you go to next. I'm going to go to this one on the far right. And I can see from the line of reflection, it's up. How far up is it? 1, 2, 3, 4 boxes. So it's up 4, which means its image from the line of reflection would be down 4. So 1, 2, 3, 4 from the line of reflection takes me down to -1, -1, this ordered pair here. And we'll just continue doing this for all 3 other points. So I'll go down to the bottommost point. I can see this is up just 1 box. So its image would be down 1 at this point. And next up, I guess I'm just going clockwise through this. This one here is up 2 boxes, 1, 2 boxes. So its image would be down 2. 1, 2, down 2, boom. There's the next point. And then this last one, so I'll do an orange. I can see from the line of reflection, it's up. Again, it's 2 boxes, which means I'd have to go down 2 boxes to get to its image here. So we can see, especially, well, I guess I'm using colors, so it's kind of pretty, but it gets a little sloppy, it gets a little cluttered in here, but as long as we can see where those points are, we're now ready to connect those points, okay? So, I guess I wanted a different color there. There's that one, this one here, here, and here. All right. Now, if you're doing this with pencil, you could say, well, maybe you draw these lines a little bit thicker so you can actually see what's going on. But I can't. But I can definitely see that it has been reflected, and I've connected the correct points. Be careful with these, especially with lots of points like this, because sometimes you just start connecting points. Maybe you connect red to orange here, or red to green, or blue to purple, or something like that. Which wouldn't be, it would just make it more cluttered. But this right here is our reflected image. 2 objectives. I can identify reflections, which we did, and then also I can reflect figures, which is those last few examples that we just did.